Are live. I'm just gonna let this stream for a little while. Finish the setup over here. Get some water, and I'm making a soup. It's more of a broth sort of thing than a soup, but anyways. If I refresh this thing over here, it's live. Are we live now? It should redirect us. You should have a progress bar, and it does. Brilliant. We are now live. Let's go here. We grab back thing. Oh, right. I wanted to share the link. The event. Here we go. Event, cancel, and I'm just going to share this really quickly in the channel that we have for Research Stockholm. There we go. Cool. We're there, here, we're everywhere. Setting up my phone to show me stats because Tweetboard is not quite ready yet. You should be soon, but not quite. I mean, I can log in, but we haven't yet done the querying for the statistics for the stream. That should be fairly straightforward after we stabilize a little how we do the requests. This is the Doom repo, which I'm trying to come up with a picture for. GraphQL, is this GraphQL? Yes. Alright, so GraphQL, ocaml-graphql sounds. Listen, GraphQL example. I don't know what to call this really. But let's do the good old setup. And we need the opam file, and we make file, and we need to keep ignore, and actually all of this we can copy over from the other file, the other project. Or was it? Twitchboard. It's slightly more up to date there. And we have the Twitchboard opam file, and we also have a done project, and we need to git ignore and git attributes. And I think this should be okay. So now we can just move this Twitchboard into something else. I honestly don't like having just recent GraphQL example here. I would like us to have maybe we can just use Twitch as an example. Example, Twitch GraphQL server. Yeah, that's more contrived. And now we can just move this into Twitch GraphQL server and rename stuffs everywhere. Here, Twitch GraphQL server. We go to the opam file. We want to call this Twitch server. This is the description. Twitch TV GraphQL server. And we can put this in Twitch GraphQL server. So I'm guessing that we're not going to do a lot of reading from disk, and we're not going to need you know what, actually, because our API is pretty closed, we probably want to use the GitHub API instead. Or we can just go back to making random GraphQL server. I guess we can use the Star Wars template that people are using everywhere. Recent Star Wars GraphQL Server. Ooh, that should just be the name of the folder, and in here we can just do Star Wars. Star Wars upon Star Wars GraphQL Server. Recent GraphQL Star Wars GraphQL Server. Same thing here. Okay, now we can easily get rid of plenty of these dependencies. So we're not going to make any HTTP queries, and HTTP kit is not ready for web, for server side. So we're removing this. We don't have command liner. We will be using the formatter for logs, and we want to use HTTP-AF, hopefully, and HTTP-AF LWT as well. And we're not going to be parsing any of this. All right, let's just see if it builds. Doing build all. Just keep watching for changes. Oops. What do you mean it's muffed? Muffed as in stay reasonable. Okay, let me check the settings, right? The volume seems to be low, but this is the output. Okay, I'm gonna go to sound preferences and just check for some things in there. And sound preferences is still making me wait. Oh, where is it? There you go. Is this better? It's pretty much maxed out. I can see here that I'm gonna have to lower this down. The volume should never have peaks in the red area. I mean, it could, but it's dangerously close to saturating. Oh yes, there is some wind noise because I have a heater on. So I'm gonna turn that off. You let me know if has the wind noise gone away? Yes, no, I don't know. Is it very loud? Is it too loud for you? Okay, because it's fucking cold here. I would rather have that on. Hey Ulrich, yeah, we're gonna be doing some GraphQL, native GraphQL. If you hear a buzz on the background, that is a heater. It's very cold here in Sweden right now. And if you smell something amazing, that's a soup I'm making. Right, I keep meaning to read this post. It's been forever, and I just don't. I don't allocate time for it. Where is it everywhere? This is the stream. Awesome. All right. Okay. Cool. I'll try to speak up a little bit. I can do that. Welcome to Reasonable Coding. I need to prepare an image like this one for when I take a second. We are now live. Today, as you saw in the event, which we have here, I'm going to make it a little bigger so Ulrich can read. We will be working with native GraphQL APIs. That is, we will explore how to build a GraphQL web server using the ocaml-graphql-server library by Andreas, what's his name? Gernes, I want to say. Garnes? I'm butchering names here. Yes. He gave an amazing talk about it on Carry On this year. It's still 2018, people. And we're going to be looking into this library for building a GraphQL server, right? So the references are here, graphql.org and GraphQL server in GitHub as well. We will be working with RC012 and Dune Thanks, Malin, for pointing out that a lot of people are asking what the hell am I coding in, and this should be copy pasta, so that if I'm in the middle of something, then anyone can just like copy it and paste it in there, or they can look it themselves by the events. It's unfortunate though that when you go into an event and it's live, it gives you like 4 seconds before it redirects you to the live stream, so you don't get a chance to actually read the description. Just a little bit of an annoyance. Yeah, hopefully we'll be able to do this in around 3 hours. The last one took 7 goddamn hours and it was not finished. I had to put some extra hours after the stream to make sure that we get a tool that works, but we did get one. And yeah, let's get started. I'll assume basic familiarity with English, words, and computers. And we'll start by talking about what the hell GraphQL is. If you already know what it is, then just say, yeah, I know, and then maybe we can skip some of this if all of you already are familiar with it. But roughly, it's a query language for your API, whereas before you used to make a lot of requests for getting, let's say, the currently authenticated user, and then making another request with the user ID to get the projects, and then getting another request to get the comments of a project by sending the project ID. And it's very easy to see how one request ends up being exponentially many more. So if you have 10 projects per person and 10 comments per project, and then you have 2 people, then you have 2 by 10 by 10 requests to send out, and that's a ton of requests, like 2 by 10 by 10, 200 requests. Good luck with the round trips. I mean, if you have a round trip of, let's say, 0.7 seconds, that's 140 seconds that you're spending just waiting to talk to the server, which is sort of insane, right? So if you have an application that uses a lot of data, that requires a lot of data, both for reading and writing, it makes perfect sense to use another way of querying that will let you specify, hey, this is all the data I actually need. You figure out how to put it together, give it back to me, in a single response. So in the example that we had before, where we had essentially 140 seconds of wait time between sending a request and getting a response back, now we would have a single request, which means we will actually be waiting 0.7. At least this is the promise of GraphQL. Naturally, if you're getting this much data, the requests are going to be slower themselves sometimes than they would in a typical REST API that just has to get one thing, right? But because you're batching many of them, then you win a lot when you're requesting a lot of data. So that's roughly it. The nice thing about what Facebook did is that they not only have a REST reference implementation, but they also have a specification. And I think that we need more specs in the universe rather than implementations. The spec has a working draft, which is what we are, they are working with, the people that work with the spec work with. So any improvements are made there, and then every now and then there's a release of the spec that says this is the version as of June 2018 and so on. And if you go in here, this is a fairly thorough document that it will load a sidebar here. Let me just make this bigger. And it has a description of what the language looks like. Oops, sorry. Of what the language looks like, right? What the operations are available, what are fields, what are the fragments, and how do you do input variables and type references and so on. It has a specification for the type system, which is very interesting. Because here you can roughly see the features that a type system has and how to map them to your favorite programming language. And it has a specification as well for how things need to run. And this is very important, right? Because if we had a specification of the query language and how we validate that a query is essentially correct for some definition of correct here in validation, but we didn't specify how the query should be executed, then essentially swapping 2 libraries might change the behavior of your application completely. For example, something worth noting is that while queries can be done in parallel, mutations have to be done sequentially. So when you request here in the example they have, right, they make a query for getting a project. If you were to do a query for a project, but also immediately in the same payload, a different query, then the server knows that it can parallelize this and get data from separate data sources or the same data source in parallel. Now, if you make a query to modify something, which is called a mutation, then if you specify more than one, right? Let's say this is called set project name instead of just project, and then you pass in the name of the project and the ID. Then each one of these little bits, it's going to execute after the other. So if you have 100 of them, you will have to wait for each one of them to execute sequentially, and then you get a response back. Which means making a lot of mutations in the same payload can be slow. You can always try to work around that by sending different requests, but of course, there are some atomicity guarantees that GraphQL can no longer give you there. Essentially, if the second mutation relied on the first mutation and you did not send those two together but separately, then the server may actually do something unexpected with your data. But yes, this is the gist. Get many resources in a single request, pretty much what we were looking through. Describe what is possible in the type system. Take a look at the development tools I have. Yeah. Bring your own data and code. Because GraphQL doesn't really care about where you run it, right? It's a language that you run inside of your language. Then you can use JavaScript or Camel or Java to build these things. Even Erlang, there's a pretty efficient implementation by Jasper Lewis for Erlang as well. I'm going to be covering that one in a few streams, maybe 10 streams from now, I think. Or maybe not, maybe less. Anyways, it's pretty well specified. It has a very nice documentation website where it guides you to what is it and what you want to use it for, like what's a query and the different concepts that it has. Roughly, I'm going to be introducing each one of them as we find them. But if you wanna just fork and take a look at this doc while I go through some other things, then that works as well. There's some best practices that are essentially, I don't know, I dislike the term best practices. It's a way of telling you that there is no better way of doing something and that you shouldn't think about it, you should just do it. I would say these are recommendations for these different topics. And there's a few that, most of them actually came out from GraphQL usage within Facebook, which is, as far as I understand, and I am not a part of Facebook, is pretty ubiquitous. Okay, so this is GraphQL, right? We have there's even a formulation for it. I'm not gonna click that link. I don't know what that is. And then we have, oops, wrong tab. This is the spec. I want to close the spec. I don't think we'll need it right now. And then we have the ocaml-graphql-server, which is a library written by Andreas to, well, write GraphQL servers in OCaml. I've browsed around this very quickly, not to spoil myself too much, because I want this to be essentially a learning experience for myself as well. But it appears that it's decently documented. There's a few things that explain how to set up servers, and okay, there's tutorials so we can follow as well. I've read this blog post before. It was, if you can have a look at it later on, do it. It's very interesting what he's doing with GADTs to encode GraphQL type modifiers. Okie doke. Alright, I don't find a beginning of a documentation. There's API documentation here. I wonder if any of those have soft documentation that we could use. So there's clearly a few packages, right? Each one of these will be a different package that we can use. And I think that before we start deciding which one we're going to be using, we should probably scope out what we want to build. If we do that and we scope something small enough, then we can get it up and running and then extend it with more types and all the things. Yeah. Okay, so this is where we make this very collaborative, and I ask you, I would like to do something similar to what they're doing with Star Wars movies here. So it will be a fairly straightforward schema that I guess most of us will be familiar with, but we don't have to use Star Wars for this. We can use anything else that we can model. So, ooh, this is big. If you have any ideas for what to model, then shout them out. This is the time. And as you do that, I will serve myself some soup. You have another new follower. Thank you, whoever it was that you... Oh, Marvel Comics Universe. All right, I like that one. Anyone else? Okay, so do you want to explain a little what you would like to model there? Do we want to do something like a hero or a person, or it will be interesting to see how we model the dual identities of some people, right? So that you can tell that a person is a superhero and the other way around. We could also model, well, we need to model the data in some way, right? So if you think about it abstractly, you have some graph, and that's kind of why we have the graph part in GraphQL. We need to model some domain with a graph where we would have some kind of nodes, right, like people, and then they will have edges, and through those edges you will connect with other nodes that are different kinds, perhaps. So you may have a kind for Tony Stark, right? Sorry, for people, that has a node for Tony Stark that may have an edge that takes you to Iron Man. Iron Man is not of type person, is really of type superhero. Okay, we can do movies and then do separate. I think an edge will be appears in, like you would have a movie such as Avengers, right? And then you have Tony Stark appears in, Avengers. But you could also have, for example, like superhero groups such as the Avengers, which is appearing in many movies but comprises different people. And you could have the Guardians of the Galaxy as another group of heroes, right? Exactly. Yeah, you're getting the gist. All right, one second. Yes, it's a window to the past. If we unwound or what do you call this? If we folded, I guess, this recursive, this inductive stream, then we get the present. All right. First of all, you might see there's this little thing bumping there in the past. I'm gonna kill that. It bumps 2 or 3 times and then it goes to the one that's below the string behind it. I think that's iTunes. So I'm just gonna kill iTunes. Forge good. And I don't need system preferences or Telegram right now. Unfortunately, there's 2. I am listening to music, and okay, so I need the rest of this. Cool. All right. First things first, I had set up a project, but it was called something different. And because no one else is saying anything about what we should model, I believe, the Marvel Comics universe, cinematic universe, MCU. All right. So we had a recent Star Wars GraphQL server, but we can get out of it very quickly. So I'm just going to move this recent Star Wars GraphQL server into recent MCU GraphQL server. And oops, nope, that's actually the language recent. If we go in there, now we just need to move Star Wars to MCU OPAM, and then we can do set. So replace every reference to Star Wars with MCU in all of the files. Wow, I didn't know I could do that. That's new to me. Okay, not in the build folder because that doesn't make any sense. But we can remove the build folder to have a clean slate. Cool. So now we can go into our OPAM project and Marvel Cinematic Universe GraphQL server. And this looks alright. No. Cool. Now let's define let's define the scope of what we want to build, and then we can start building. Right? We want a server. I think I'll take a small detour before so that we can more clearly evaluate the results of what we're going to build. GraphQL has this capability of introspecting the type system, which means from the outside of, it sounds like a deep thing, you know, that people do, introspect. But it's essentially something that from the outside you can do, which means you can see what the schema, what the GraphQL, what the graph that is represented actually looks like from the outside, which means you can learn what are the different types or things that are in that graph. So for example, from the outside, I could say, hey, MCU GraphQL server, I honestly don't know what you're about. Can you tell me more about yourself? And MCU GraphQL server will say, oh yeah, sure. I am a GraphQL server of this version, and I'm working with these types. I have some superheroes, and I have people, and I also have movies, and then I have superhero groups, and so on. And there's a very nice tool for working with this thing called GraphQL. Here. Right? And this tool not only is installable locally. Where is it? No? Can I? Okay, I'll just show you the tool first, and then we can. Huh. GraphQL. I wonder if they have an example. No, okay. I should have prepared this link. Damn it. I don't think this through. Right, let's align them here. Perfect. So this is the tool, right? GraphQL. And this tool is configured to point to a GraphQL server. And when it begins, the first thing it does is, hey, it talks to the server and says, I need to know what you're about. And the server comes back with this thing, the data that populates this view. It comes back with a query and a mutation root type that when you open it, it defines different subqueries. And these subqueries are things that we specify in our schema, and they of course are described by types, such as, for example, planet or film or person or species or starship. So if we go into let's go into the person type, we'll see that the type of person is an individual person or character within the Star Wars universe. It has a name, these are some properties that they have, and so on. So what I'm thinking is, as our evaluation criteria for we're done with this, we could try to run this tool against our server and essentially be able to explore this and see, oh, okay, the types that we need are in place. That could be the first step. And then we could try to run queries against this server and not only get the types we need, but also get the data that we need. So we'll begin by just saying, no, I'm actually going to make a repo for this thing. Recent MCU GraphQL server, and then description, we can update it later. So I'm going to add the repo. Recent MCU server, the kit. And we can just say initial commit. Don't look at my password, and we'll just put everything in there. All right, loaded, perfect. We're pushing. It's pushed. Nice, good. Here it is. Ta-da! All right. So first things first, to be able to evaluate this thing, we need to be able to run GraphQL somewhere. And I would like to run it locally, separate from this project, so that it doesn't obstruct us. But I would also like to know if the tools actually serve it. And they do. There is a sample GraphQL server somewhere in here. But I'm going to go the easy way of GraphQL, check if it's installable by Brewcask. And if it is, great, then we can just use it. Awesome. Awesome, awesome. And there are some tabs. Yes, there is a GraphQL app. Hopefully it's okay. Hopefully it's just an Electron view or an Electron box. How do you call those things? I know that you, Fernando, probably know. Electron boxes, Electron windows, Electron packages. I'm going to close this thing over here. We have the repo, we have the library. We don't need the GitHub API for this thing. That's another thing. Alright, cool. So now we should try to run this thing, and we get a GraphQL here that we can use. Oh, right, I had downloaded Insomnia for this. Okay, let's see which one does best. And now I remember why we had the GraphQL API from GitHub, because I think that GitHub has an endpoint that we can use right now to test the tool. I don't know. Let's just figure it out. API.github.com, I guess. Method post. It's fetching something. I don't think it's working. I'll just go into the endpoint and see what's in there. No, just, can you please, sir? Oh, I'm missing a semicolon. Sorry, a colon. Okay, so in here, is there any reference to GraphQL? Great, that didn't work. GraphQL API. Some company has to have a GraphQL API somewhere around here. Or we can take a look at the one that we were using in the graphical example. If we go to graphical, they have a live example here, and this live example has got to be querying something somewhere. So let's check that out. Well, okay. It seems to not be doing that. It seems to be downloading the schema, which is a sensible decision given this is a public tool. Who else has a public GraphQL API? Thank you, API gurus. Braintree, Tribe, Recos, GitHub. Okay, so they have an Explorer. Is the Explorer going to be... Okay, the Explorer is essentially graphical. And I need to sign in with GitHub. Oof, so many things to give access to. Authorize. No, I don't want to give access to other people. Followers, Yelp, Universe, Discord. Okay. That did not go well. No, it's Spotify. People. Well, we could also try it out locally once we have something set up. But in essence, we put the endpoint here, which is a URL of where the API lives. And this will just query that for the schema. It will show us the documentation here, and we'll be able to send queries to it. And I think we should evaluate our GraphQL API this way, because if we were working with it on a daily basis, we would definitely be using something like Graphical to take a look at what's out there, if it's nicely documented, if the field is properly marked as deprecated, and so on. This will be essentially the end user result, where the end user, of course, is another developer. All right, cool. So that means that we need to install some libraries. Let's begin by adding readme md here, and then let's do Marvel, Cinematic, Universe, GraphQL Server. It's not as catchy as Swappy, but you know, MCU GUS. Scope. We want to model characters, let's say people, superheroes, and what else do we want to model? We want to model movies, right? And superhero groups. And this could be Shield, Avengers, Guardians of the Galaxy, and so on. So we can start with these things. Let's begin by making the people query available, right? And then we can add superheroes and relate them, and then we can add movies and relate them, and then we can add superhero groups and relate them. Does that sound alright? Any changes in scope and so on? Oh, nice. Okay, all right. We got some with a link there that we can actually use here, apparently. api.graphql, sorry, github.com/graphql. Requires to be authenticated. Oh shit! Oh, this was warm. Oh, sorry about that. Got a gulp of soup that was just too warm for me to take. 1 second. All right. So we need to be authenticated, but essentially we'll put the URL there, as we said before. Cool. So if this looks all right, we want to model a person, people, superheroes, movies, and superhero groups. We'll say a person, right, should have first and last name, and we'll say they have hometown. Right? Sounds good enough? We can start with this, and then, add more data as we go. So when we query for a person, for the list of people, we should see, and we can list here Tony Stark and Manhattan, and then we can see, I don't know, Thor, and was he New Mexico where he fell fell down? New Mexico. And let's do anyone else? Any requests? Okay, you wanna use Oscar? Okay, Oscar. Fine. Okay. Any requests? Scarlet Witch. Gamora. Gamora is from the Guardians of the Galaxy, and where is she from? I don't know. Let's look that up very quickly. We might do this a lot though. Gamora, MCU origin. Yeah, of course. I mean, who doesn't know the full name of Gamora? Appearing created by Jim Starling, adopted a power includes for stranded planet. But where is she from? Some berries. Anybody knows where she's from? Where is Gamora from? Gamora from. Google will help us. Fine. I don't know. So let's do a known location. Gamora. This would be Thor, Odin, Son. And this would be, oops, Gamora. Just put that there. unknown location. Okay, that sounds like a requirement that we can set up and we can accomplish from space. So let's go ahead and do this. Let's make a GraphQL schema that models this this little bit here, right? And let's begin by pulling in the actual dependencies that we want. So let's actually see some code. I'm just gonna make a source folder and I'm gonna make a schema module here. I don't know if you're gonna need it, but oops. And let's do server module. So those are two separate things. We're gonna need to install the ocaml-graphql server, which I reckon is gonna just be a GraphQL. And we can use the LWT one, which is the essentially the IO monad that we have been using for the past 12 streams. So we'll need this one, and we'll need this one. Okay, so GraphQL LWT. Yeah. And then we'll go and define the schema following this tutorial, which is more of a code sample, but you know. Okay, let's do that. Installing, let's make sure that we list them up in our dependencies, right? GraphQL, and we need GraphQL LWT. Yes. For the curious, the reason that we have these two packages is that GraphQL is doing something very cool, which is it defines everything it needs to work with a GraphQL server, but it does not know how you're actually going to materialize the server, which means if you wanted to use a promise-based library or a synchronous library or what have you, then you can just use that instead. You can extend it to have your own runtime. You will see that as a pattern in other ocaml libraries, like this HTTP web framework. Okay, so now that we have those things, we can begin by creating a schema. So if we do a schema.re file, right, then we can open GraphQL, and then we should have access to a lot of GraphQL things in there. In fact, you know what? Just for so we get used to not opening things all the time, we'll just begin by putting the name GraphQL everywhere. And one thing we're missing is two things. One is starting a server that will watch and build everything all the time. This is not a requirement, but I like it because I save a file and I see immediately what's wrong with it. And the other one is that we need to tell the build server that this folder and these files are actually a library. So we're going to call this thing schema, and we're going to import the GraphQL packaging here. So if I save, then we should see something building on the left. Great. Which means if we try to open, we already have GraphQL here. And if we go into the module, we'll have a schema. That's the only thing inside the module. And if we go again, we have a bunch of types and things in there. Great. Okay, so now let's look at the example and see how they're modeling stuff. They define a type, and mind you, this is an ocaml type. And then they have a user, which is another type, a record. And then they have some data. All right, so this is the mock data. Brilliant. We can do the same thing. We can begin by defining a person, right? And a person, as we saw before, will be a record of a few strings, like first name and last name and location. And we can use location as a string for now and type it more tightly later. And then it goes on to say this is the type user, essentially the equivalent of our person. Then it goes to say that there will be an object in the schema, right? It's using the method object, but it's using a local open. So we get access to everything that's inside of the schema module for free without having to type schema dot all the time. And in here it's using a few, okay, so this is a function clearly. Takes a string as a first parameter, takes a name parameter called doc, that is documentation, and takes some fields, which I take is a function that returns a list of whatever the function field returns, which I reckon is a type for fields. You'll hear me say I reckon a lot because, yeah, I don't know what I'm doing right now. So if we go and we look for the object function here, we'll see the signature. And as you can see here, if we give this thing a doc string, a name, I'm assuming this is the name because it's the only mandatory parameter. And then, no, the fields are also mandatory. And then the fields, then we come back with an object that is part of the GraphQL schema type. And I reckon this tip is a type that represents the whole of the schema. Okay, so we can do that. We can say object, and we will say person will be type, right? And then we can give it a doc string. We can say a person in the Marvel cinematic universe. And then we can give it fields, and this is a lambda as well that takes a function that of one parameter that we ignore, and should return actually a list of things. So if we save there, just for the auto formatter to kick in, then we can take a look at the type of this whole thing. And this is a GraphQL tip of some A that we have not defined, and some optional B that I have no idea where it comes from. Okay, so going back, we'll see that we need to define some of these fields, right? My guess is that this P over here, right, which is where we're accessing this attribute on, has to be of a type that unifies across all of the fields, and thus unifies across this particular object. And because I remember that we have ID, name, and role in user, my guess is that when we add fields that match the attributes of our record, then our schema object for a person will be bound to the type person. So let's give that theory a shot and say there will be a field, and I can't remember the signatures of this thing, so I'm just gonna look it up. By the way, I should have mentioned this before, but normally in this setup that I have, at the bottom left of the screen, you'll see this here. I'll just highlight it so that it's obvious, right? This yellow part. This is the type information. So if at any point that I mention that I'm going to look at the type, or I say let's see the type, just draw your gaze to the bottom left side of the screen, corner of the screen, and you'll see the typing here. Here on this side, in this block that we have here, the yellow one, is where all the compiler errors will appear. And in here is where we're going to be running our server. And naturally, you may have guessed already that the thing that we see on the left, this part, right, is, this is my editor. This is good. Okay, just wanted to make that clear. So now I'm going to take a look at the field type definition, and we get doc, deprecated, and a string, which should be the name, and so on. Okay, so let's just do field, and let's just give the name first. We want first name, and you might frown upon this, but okay. Normally, I think people would expect with GraphQL API to use camel case things, but because we're here and we don't want to do the translation manually all the time, we're going to use the same name. This can be easily automated as well to just define everything with snake case, which is normal in camel, and then just have a piece of program rewrite those snake cases into camel cases for you. So don't worry too much about it. One second. And I'm back. Cool. So now we have a field, right? And when you look at the type, we'll see that we still have all of these other things. Some of them are optional, like the docstring and whatnot, but some of them are not optional, like the arguments and the result. So I'm wondering what exactly the args will look like for this. And we're going to go back into the sample, and we'll see that it has an argument, that's arg empty, has a type, and has a resolving function. All right, we can do this. Let's begin with doc and say the first name of this person. And then the arguments will be no arguments because it's a very simple value. It doesn't make sense to make the first name parameterizable. At this point, it might make sense at some point to say, give me the first name in reverse order, or give me the first name translated to a different language, because who knows if all the languages are translating the names of superheroes. I know that in Spanish we have translated Pinocchio into Spanish. It's Pinocho. So Pinocchio, or something like that, to Pinocho. Tomato, potato. Okay, and then we need to give it a type. And this type might not be obvious to you, but this type is the type that we want to expose to users through GraphQL, right? This has nothing to do with the type that we're going to use internally. So when we say int here, right, this int is not the same int as here, because this is the name of the int type in OCaml, and this is the name of a function called int, or perhaps a value called int. We'll have a look at that in a second. So we have tip, and the tip, and the tip should be non-null, and then we have a lot of things in here because we are inside of schema. So maybe if we go to GraphQL schema, we will see that we have a function here called int, or a value. It's a value, and we'll have probably a value called string somewhere. There you go, string. Cool. Naturally, because we're inside of the local open in line 7, we can just say goodbye to this thing. Bam, it goes away. Cool. I'll just keep saving, and the build thing is going to fail at some point. And we're missing one more thing, which is the resolver. Now, the resolver is something that we have not talked about before. Resolvers are functions that once someone from the outside, right, requests something to you, you will use to fulfill that request. In essence, if someone, and I'm going to make a comment here, if someone says, oh, okay, let's say we have a query that's called all people, right? And then, oops, sorry, where am I? There you go. And then we want to get the first name of all people. We don't need the parentheses there. The fact that we've defined this query to have the type person means that for every field that we specify here, right, the accompanying resolver for that field will be executed, which means if we say first name here, then the function that we're about to define in here, that has info and has a person as parameters, will be called so that we figure out how on earth to get the data from the context that we currently have to fulfill this value, to fulfill this field's promise. When I say promise, I don't necessarily mean an asynchronous computation. I just mean more informally, someone promised me something and then they did it or they didn't do it. And resolve, if I remove this thing here, we'll see the type that it has. Resolve takes some A and some B, right? And then it returns you a string, which is the type of tip. And sorry, resolve takes one function that takes some A and some B. We don't know what those are yet. And based on that, it will return you a field, which is what we actually want. So if we give this resolve function, we say context and we say P for person, what we kind of want to return, if we get a person, will be the P the first name, which is the name of the person, which happens to be a string as well. And we're not using the context, so we can ignore it. I am so confused. Why did this not get inlined? Like that. Okay. It appears this is the right formatting for this thing, which I find very odd. But as you can see now, the field, right, has for second parameter a person, right? Which means all of the resolvers that we're going to use here are going to be working with a person. So if we duplicate this thing and we throw in another field for last name, the last name of this person, we can say last name, and slowly this will start to take more shape. This now becomes a list of fields of some context that we don't know about and a person, and then the object that we have here, right, becomes an object of some context that we don't know about and an optional person. You may not like it, but all of the fields in GraphQL by default are nullable. And this is to aid schema evolution. It's not nice or elegant, but it's really practical when you have dozens or hundreds of developers just cranking their fields into schemas, and you honestly don't want to be able to fill them, or you don't want to have to always return them, and so on. Essentially pushes this responsibility to the UIs, which is, of course, something that other people will have to deal with. But I mean, it just defers the problem. It says, I'm not going to have this issue here. You have to deal with it somewhere later. And where they currently are, or where they are from. Did we say location, or did we say something else? We said hometown. So we're going to change the schema to say hometown, right? And then location will be home. Where you're from. And of course here we're going to extract the hometown. Cool. Alright, so we have a person object that looks pretty much similar, very much like this one. I will grant you that the OCaml formatting for this is much nicer than the one that we currently have in Reason. I do not get this very weird new lines in the functions. Super strange. Super strange. But anyways, this will be our person. And because we have a namespace for types that's different from the namespace from values, we can have a person here. And now we have a problem. It says that it cannot generalize the weak variable that's on the left. Weak variable, type variables are variables that the moment they find a match, they will be replaced by that match, which means the ordering in which they are matched, it matters a lot. So in a function like, let's say map, right, that takes a function from A to B, A to B, and it takes a list of A and returns a list of B, and then we don't care about the implementation right now. If this was actually a weak variable like A, then when you give this map function a first list of ints, then this map function can only be used with lists of ints forever into the future. But if you don't, if you keep the underscore, if you don't have an underscore there, it means that this will work for ints or bools and whatnot. And if you know more than I do about the subject, please call me out on my bullshit if I am saying anything that is wrong. Yeah, I can do that. Cool, that builds. So now we have a person. Great. And this person is essentially just one of the types that we will have inside of the system, right? Inside of the schema, the graph. And we want to define an actual schema now. Now I'm going to be struggling a little bit with the terminology. The experience that I have building GraphQL services is JavaScript and Java, unfortunately, and the terminology is not always the same. Okay, so then we need to build a schema, and the schema will also have fields, and this field will have a type, right? And then we have some arguments, and then it has a function that results. And because we're using the type that we defined above, then the resolver is also bound by that type to return anything that looks like this. Okay, cool. So now we can go down there and say this will be your schema. And we have a schema function that doesn't take a name, it just takes a list of fields. And each one of these fields will look very much like the ones that we have above. So for a field, we will have, like, let's say people, right? Which will be all the users, all the persons. And for documentation, we'll say all the people in the Marvel Cinematic Universe. And then we don't want any arguments right now. We just want to get all the people all the time. And we need to define the type of this thing. We want to say the type of this thing will be, we will always have people, right? So it's a list that cannot be null of person that cannot be null. That means this might feel silly for some of you, but not only can the elements inside of a list sometimes be null, so sometimes you can get like Tony Stark, and then null, and then Pepper Potts, and then null again. But also the whole list can be null, right? We don't want a list that is null, so we go non-null list. And we don't want any null elements inside of the lists, so we go person non-null. And now we can actually have a result function, and this result function will take a context that for now could be the unit. And interesting. P will be the data that we get back, info. I guess we're ignoring, there is something that doesn't quite make sense to me right now, which is this unit. But essentially, if you give me two units, right? The first one is the context that we define over here. If you give me two units, then I will just give you a list of people. And we need to define this list of people somewhere. So if I save this thing, now we have a schema. Sorry, there we go. And now we need to build the data, which let's do in a different. Okay, let's just do it here. People, and this would be an array, and we can do first name, Tony, last name, Stark, hometown, Manhattan. and then we said we were going to do this other two, so I'm going to copy them here. Yeah. Then we go to the first name, Thor, and then last name, audience song, and then hometown. That's great. Okay, let's just say the first name will be Gamora and the last name will be this thing. The rest, which is very long. Gamora and hometown will be unknown location. Cool. So now we have a people and we return a people, and this actually type checks. This looks super funky. Not only I really dislike the new line on lambda there on the function, which I don't quite get, but the dual units, I get the first unit for the context, but what's the second for? How to know, you know? It's hard to know. Okay, so now we have a schema, and we can run a query against it. So this is structured like a tutorial, sneakily so. It doesn't say that. It says examples. So now let's try to run a query. And there's a parser that can parse essentially a query string, which is very much like the queries that we run in GraphQL, right? In here you will write something like this, and you will say like people, and then in there you will say for each people give me the first name and the last name. But we're not quite at the point where we can use GraphQL yet. I'm going to make this also bigger. We're not quite at that point yet. We'll get to that in a second. And I'm going to ask Ann Montero, we'll see, it's in the chat already. Welcome, by the way. Can we use HTTP AF with the GraphQL LWT module? Please tell me we can. Oi, oi, oi. I will take that as a yes. Okay, so if you can send me a link to a specific bits and pieces that we might need to hook things up, then great. I will refrain from looking at the completely built example so that we go through all of the pain points, all of the steps, one by one. So now let's try to run this query and see what we get out of it, which I don't know. Sorry, I have a no speak. I don't really know what it will be like. Perfect. Thanks. Thank you so much. We already have a server package as well, so this fits like a silk glove. I think that's only a Spanish expression, but I don't know. We also have like ring to finger, which I don't know. Anyways, let's take a look at what the type of this thing is, and what the type of this thing here is, and what the type of this thing here is. So if we have a schema, and we'll just do this in the same module for kicks, we should be able to call GraphQL parser, and essentially there should be a parse function here, parse, that has a type string and then a document. So if you give it a string of a query that you're running, like for example, do we need to include the top level? No. All right. People, and then first name, right? We can add more fields, but put comments in there and so on. But we can do with the first one. If we do parse first name, then we can essentially switch on this thing. And if it's okay, then we have a document. Oops. And if it's an error, then we have something here. This is error. So when we do have a document, I'm just gonna close this thing. So didn't manage to type. 1 sec. Saving. Okay, type it for me. Good. We have a document. We can try to run, try to execute that document with this schema that we define here and some context. So essentially, what is the value of this query, right? If we start with this context on this schema. And GraphQL, and somewhere here we should have schema execute. Yeah. If we look at the parameters for this function, we'll see that we have first a schema, and then we have a context, and that context is the same context type that the schema is parameterized by. Then we have some variables for the query, and then we have an operation name, and then we have a document. Huh. Interesting. So what we get back from here is an already JSON parsed. It's either a single response or a stream of responses. Sec here stands for sequence, and I understand is the standard library stream type. So we have a GraphQL response here. Okay, let's see where we get. So the first is the schema, and then it is the context, which is just a unit type for now. Remember, we were using unit here, and here, and here, and everywhere else. And then we have the document. When we save this thing, of course, this is going to tell us that the types don't really match, but that's okay for now. Now we know that we get a GraphQL response out. Huh. Interesting. So what is really a GraphQL schema response? Let's ask the type system. All right, so it's a result that has something from an OK, right? And the error is always going to be some JSON. Which means we can essentially match on this in the same way. And we can just extract something here. So we can, let's say, result, or let's say data. And error, we have some error as well. And the unit for now, so the formatting works. And this data will be either a response, which is some JSON basic JSON object, or will be a string. So we can also just match directly here, and if it is a response, right, then this thing here will be JSON. But if we do have a string, then we can ignore this for now. And what we're going to do is we're going to take this this JSON, and we're gonna print it. So to do this, we wanna have a small binary that we can run very quickly, so that we print out the results. So instead of running this module, I'm just going to create a new folder called bin, and let's just paste this thing in a file in there. So let's open source bin main RE, No, what happened? I lost the paste buffer. I lost the paste buffer. Cool. So now we need to do schema, schema, and we need to tell it that this is a different file. We need to say something like that in here. So this would be executable main, and then public name would be this query. And for library, we want GraphQL, but we also want our schema library. Cool. We have a few things that we want to ignore for now, just to see that this thing works. Perfect. So we don't really care what happens on the stream, or the error of the execution, or the error of the parsing right now. Of course, if we were building a proper tool for running GraphQL server queries, we will definitely want to handle those cases. But right now, we just want to take the JSON and we want to essentially print it out as a string. So we saw that this is a type JSON basic JSON, which means we want to use that particular library to print this thing into a string and put it outside. So let's do that. Let's do let JSON string will be JSON and then basic, and then I think this should have something like toString that we can put the JSON in there, and then we can just print that out, which we don't need to use this variable at all. Printf, printf. All right, just one small thing. There you go. Which means now we should be able to go to build, default, source, bin, main, and run this thing and see something out. I have no idea what will come out. I expect it to be an object that has a data key, and the data key should be an array of objects that have, no, sorry. The data key would be an object that has people, that's an array of objects that have the first name, and we should see the Thor, Tony, and Gamora. Right, that worked. So we can just pipe it into JQ and we get a nice representation out. By the way, if you're working with JSON every day and you have not started to use JQ, go ahead and install it right now. It's a tool for parsing, for essentially working with JSON data on the terminal that lets you run queries and essentially manipulate data as it's streamed. It's very useful for things like what we just did. Okay, so we get exactly what we expected it to be. Data is an object with people as a key. That's an array of objects with first name as a key, and Tony and Thor and Gamora as the values. Brilliant. Perfect. Now, how can we actually, get out of the terminal and go into a place where everyone else will be happy, not just me? I think that'll be a little harder, but we'll give it a shot. I'm going to take a 1 minute break to go to the bathroom and get some more soup. And when I'm back, we're going to be looking into this implementation of essentially how to run a GraphQL server, right, that runs over HTTP. Server static, it's the thing that we saw the other day. Okay, execute the close. Very good. Yes. If you've been here through the serving static files, a lot of these serving static files with HTTP AF stream, a lot of these will be very familiar. If you've been here through the last stream and querying things as well, plenty of these will be very familiar. Right. I'll just leave the stream here so you can see yourselves in the past, like a few minutes ago. Oh, and if you're liking what you're seeing here and you want to help me out, spread the word, just tweet or retweet. There's that. I think I tweeted something recently here. Yeah. going live in 2 hours. I guess we could just change this to be live now. Yep. Okay. I'll be right back. Almost here. Almost here. Right. So where were we? We wanted to serve this thing over HTTPS. That's right. Well, that's from yesterday. That was quite a battle. We want to serve this over HTTP so we can use a tool like GraphQL to explore the schema, right? Because right now we can query it and we can fairly straight. It won't take too long to essentially pass in the first parameter here, right, as a string from the command line, and then you have something that you can just write the query as people first name, right, and then it just gives you the result back, and then you pipe that to JQ and it works. It wouldn't take long to do something like that. Which, by the way, this didn't. This definitely didn't. It just ignored the parameter, right? But we want to be able to explore the schema rather than build tooling or be able to script calls to it and so on. We want to explore it more visually. So let's take a look at how we can do that. Clearly, our main file will be useful to run something, right? So maybe we should keep it, but maybe not with this. So we'll remove some of this stuff. We will be depending on GraphQL and Schema, but then this will be something like MCU server. That will be the name of the file, of the executable. Okay. So given that we have our schema, and we have some data here, if you don't mind, actually I will put this data in a separate module. Source data. Okay, but this is going to introduce a dependency between the OCaml type definitions, the data, and the GraphQL type definitions, which makes me think that we will have to split something else out, like the schema will be one thing, and then the model will be another thing, and then data will be another thing, and then you can restore your sanity. I mean, you can break the cycle of dependency. So maybe not. Let's just keep this for now as it is, and we'll expand it later. All right, so having the schema there and some data that we can use, we can go back into the examples and take a look at how on earth were these things being built. And I think Ann Montero sent a link that I no longer have, damn it, but it should be somewhere in here. Yes. And he actually has a recent GraphQL experiment, which is great, where there's some more things being built. He clearly has a server package, you can see from the URL there, which we do, ironically. There's no irony in that, it's just coincidentally. That'll work. Yes, out of coincidence. Cool. Now we just need to fill this thing in with a proper server implementation that will take some schema, and then we'll run the server and just print the queries out. So we can begin by sketching out what we want it to look like. So if we go into main, the first thing that we would like this thing to do is to do server, and we can do start, and we can just say schema. And we give it a context, which is in this case empty. So of course it's going to fail because we don't have a server module anywhere. We can get that up and running pretty quickly. Source, server, Dune, and then a library, and this would be name, server, and this will depend on some libraries. So far we know it's going to be GraphQL, so that we can execute the queries, and we will need to depend on the schema. No, maybe not on the schema directly, but also we will need to depend on GraphQL LWT because we need to run things through LWT, and that means we will depend on LWT. And while we're at it, we probably want to do some logging around when the queries come in and out, and we'll need formatter for that. Okay, this sounds like a start. We can always improve from here. But now we have a package called server. We just need to define the module, which means if we open the server RE file, we create one new, right? We save it, then boom, now we have a module there. No, my bad. We need to add it as a dependency to the main package. Great, and after we do, it says that there is not such a thing called server start, which means we can say here schema, context, and we can return unit for now. Cool. So it doesn't really know what type these things are, it just knows it's a unit. That's okay. Okay, so in here we will want to do something, right? And by something I mean we want to do set up the HTTP server, right? And we want to essentially keep the server running as long as we can. Also, I mean continuously, so it doesn't finish once it reaches the end of the. It doesn't finish immediately after setting things up. And when we set up the server, we want to pass in the schema and context. So the response handlers can use it. Okay. Now I forget, but this syntax and comment actually doesn't quite work. Thank you for ordering that for me unnecessarily. All right. So let's take a look at how we can do these things. We can keep the server running forever, essentially by making a new promise that will never stop, and just telling the LWT runtime to wait for it. Okay, LWT main. I think we're gonna be needing another package. I think we're missing LWT Unix for this. Yes. Cool. So this means whenever this function is called, it will do some things, and then it will create a promise that never ends, and it will just wait for the promise. And it will be more obvious why in the future. This will be a very low-level HTTP server. I know Montero has some ideas about how to make higher-level ones. I myself also have some ideas on how to do it. I'm going to be putting them together in something I'm calling HTTP Kit in here, if the internet doesn't wait forever. Yeah. Right now it has nothing for servers, but in the future it will have something. Hopefully Montero and I can collaborate on these things and make really, really high level, cool to use, and also incredibly fast and secure APIs for people to build web services and web clients with. Oh shit, this is still very warm. Water break. Sponsored by the universe. Okay, so if we look at the start they have here, it's very similar to the one that we have, where we end by saying just wait forever. But in the middle, we're going to be doing a few other things, which is creating a listening address with a port, and then essentially spinning up a lower level a socket connection to essentially keep the server running separately. So what really is going on is that we will dig really deep compared to what you would normally do when building web services in other languages, and we will be establishing connections directly with Unix sockets. So the language itself doesn't really know what's going on, right? It's the socket that does the reading and the writing, and there will be callbacks to those sockets, so that whenever something happens on the socket, then a function inside of the language gets called with the data, and then we can work with it. I understand this might be a little uncomfortable for some people, but we'll get to something that's a little higher level in a second. So there's a few things that we need from here, there's a few things that we don't. I'm seriously considering, because you pass in a context and a schema, I'm considering just stripping some of this code away and reusing it. Make a connection handler, that's pretty much the same thing we would have done before. You need a request handler, an error handler. You return it here, connection handler. No. And then you're making callbacks here, which I guess this is your request handler. In this, you get the path from URI. You log where you're actually requesting this thing, and then you split by a regexp. Right, and then you do the routing. Okay, so all of this get and post are that we have over here, we don't actually need, if I understand this correctly. Bar, full bar. But having a post GraphQL would be useful to be able to post the queries to it. All right, I think we can write this. So we also do some muscle memory training. We have plenty of time, so let's do this. Step one, we will want to essentially get an address. So you get a listening address, and this comes from the Unix module. As we saw here, it's just a data structure that we build up. So it was address, of course, the local open prevents that from being open. And we have an internet address, and we have Unix socket addresses, domain sockets. So here in the init address, we can use different loopback interfaces. What is it? Init? Yeah. Sorry, different. Are these interfaces? I think these are interfaces. You can use any interface. You can use a loopback interface. You can try to build an address out of. Sorry, these are addresses of the interfaces. And then we probably want to do loopback here, so we use localhost, and we're going to use for port now. We're going to pass in the port. It's number, and we're going to use it here, right? So with that address in mind, now we need to begin the actual server. That is, we need to connect this thing to a socket in Unix to be able to read and write from and to it. But we don't want that to happen in a blocking way necessarily. No, I think we actually arrived to the conclusion that we don't need to block or spin an asynchronous computation here. We can essentially just do LWT, the IO. I think this would be Unix. Actually. Connect IO. Establish server with client, and we have an address. Where if we give it a socket address, which is the type of this thing, and if we give it a function that will be the handler of the thing, then it will give us a server. So if we do listening address, and then here we can say connection handler. And because the connection handler is the one that defines the request handlers and the error handlers, we want to actually give it the schema and context so that it knows how to build what it has to build. And then after this, because this is just LWT IO promise, we can sequence, and immediately afterwards we can just say logs LWT and just debug. Print out a statement saying that the server is already running. So server running at HTTP, and then this would be localhost, and then this would be port. Yes, we can port, and that should be it. Cool. Great. So now we can define our connection handler. You'll see this is very boilerplatey, but we need to get a schema context in, and we will need to return something out, and that something will be defined by this function. So the function that we need to return, right, should have this signature that we see here. And I've seen this problem before, so I wonder if this is with socket rather than address. And yeah, interesting. There you go. Now the signature should be more like what I expected it to be. Exactly. So now the signature goes into this instead. We need to return a function that will return. So we'll have some two types here, right? And then we'll return a function that looks like that. So at the end of this, we have handler. On this handler, we take a socket, a file descriptor, and the socket will be the client actually. And we'll take a file descriptor, which I don't remember what it was for, and it should return a promise. So we can just say return unit. And this is not working because we're missing the colon there. There you go. Almost, not quite. That's not what I wanted. I wanted this. It's equivalent, but yeah. Okay. So now that we established the server with a client socket, right? This client socket is a socket that any browser is going to connect to. We have passed in the address of that socket, but also we pass in the connection handler. And this connection handler is this function that we see here, this handler function, that has access to the schema and the context, and will define how the hell we will reply to requests, and also how we will handle some errors that will arise. So okay, if you're going to be using HTTP, all right, we need to use this little bit here, which means the connection handler will actually come out of this thing. Right, that makes sense. Okay. Request handler, he's trying to make a callback asynchronously. And the error is trying to build the body back and return it printed. Okay, so the request handler in here is actually not caring too much about the address of the client, but it is using the request descriptor. And it's going to use the request descriptor, this RC type, to get access to the actual request, such as the target, which is the path, or the headers that have been sent, or other things in it. Okay, so let's begin by writing this. Let's do a breadth first, right? Let's go into what we need to define, and then we'll sketch it out, and then we'll fill in the things that we need to define. We need a request handler that looks like this, right? And then we need an error handler that looks like that, and then we'll need to return the connection handler by using them both and passing no connection to the eligibility port, or sorry, IO monad applied to HTTPF. So we can start with the last thing here and then work our way backwards. So our handler essentially will be something like this, right? You take the client, which you forget, and this will be the request descriptor, and then you return one of those. We will need to get access to this module, which we don't have yet, and I wonder why. So we'll open the server Dune file and take a look here, and we don't have it yet. So we need HTTP AF. And by the way, AF does not stand for as fuck. It stands for Armstrong Faraday. Have a look at it. It's really, really impressive zero copy parsing library. I still don't understand how it works. I am baffled by it. Cool. So that means we need to define what the hell a request handler is and what's an error handler. And we can do this separately. You can say request handler, and we'll give this thing not only the request, right, but also the schema and the context. And also the error handler, we can say error handler, and this thing we can take the request, the schema, and the context. They will take some more parameters after we give them those, but with those we already have everything we need to make the things available. So I mean, what I'm saying is we're threading through all the parameters that we need. So when we define our request handler over here, request handler, Then we get the request descriptor, the schema and context, and we can do whatever we want to return one of those. So let's take a look at what's going on in here. The request handler itself is actually fairly simple. It might actually make sense to just inline it, right? Yeah, I'm confused. Okay, I've done something wrong. We don't actually have... Yes, I am confused. Right. We don't actually have the client yet. We will have the client once we handle a connection. And that makes perfect sense after I say it out loud. But it didn't before. Of course, this is all the information we really have, right? We can create a handler for this. But it is the request handler itself that will get access to the address and the request descriptor whenever there is a request. Before a request, we actually don't have access to the address of who is asking for something, who's requesting it, but also the descriptor of the request, which tells us what actually is being requested. And that makes sense. Right. So now we can just we can call this async. Will returns a unit immediately and schedules this computation to be run at some point, which is pretty much what we want to do here. So we might as well inline this definition, and we'll say that there is a client that we don't care, client, but there is a requestee that we do care about, and in here we can just say handler request. And we can pass a the schema and context. Cool. Otherwise, we'll have to ignore this parameter somewhere down the line. I hope this does not end up in that weird syntax that we had before. No. Okay, this looks okay. By the weird syntax, I meant the one that looks like this. So why? Just why? Something to fix and reformat, maybe. And the error one essentially takes a socket, which is the client, takes a request. We get the request object, that's optional. Thank you. I've been looking for how to do this in the past. I just haven't just thought, but maybe we could alias it to underscore and then do equals. I was trying to do underscore the name, and then of course the name changes and it's not the same thing, and it doesn't match the signature and so on. Okay, so I'm not going to type all this again. It's a little bit unnecessary, but essentially we will have a function, right, that will work as our error handler that will ignore the client address. Sure that. But it will log out the error and start of the response. And I wonder why the start of the response has to be... so it's a function that if you give it some headers, it gives you a writable body. Interesting. So what we're doing here is we're extracting the writable body from the start response, and we're going to be writing into it. We're going to write the exception string that we have with a new line, and if we found any standard status default reason phrase, okay, and then no, this is separate. It's either or. But if we don't find an exception, if we have any status, we're going to use the status default reason phrase and write it in there, and then we're just going to close this thing. Okay, this looks straightforward enough to just copy and drop in there. I'm not a fan of copy paste. Okay, so this little bit here, we can 100% this originally from and we'll reference it directly, giving credit where it's due. Oh my god, this soup is so nice, so warm, so cold in here in Sweden right now. What's the weather wherever you are? Right, so going through this, when you call start response with an empty header, you get the body out, and this is not any buffer or any string that's mutable. It's a special, let's say, sort of buffer that you can write things to, because in the signature is parameterized by this polymorphic variant that says this is writable. If this was read, right, or read or write, then some functions might not run as nicely or run at all, compile at all. And we're going to be writing some of these things, and then we're going to close it. And it is my understanding that once you close the response body, right, it's when the HTTP AF framework knows that it has to flush. Essentially, it has to. Okay, what? That's a. I'm not entirely sure about that. I know that there is something called body flush. Whoa, isn't there? Body HTTP, yeah, body flush, yes. And I'm confused. We need to do holy crap, what's going on? Is anyone gonna finish that and finish saying reasonable? Thank you, naysayers, for hosting me. We're doing some ReasonML here. We're trying to build native GraphQL APIs. Okay, so we need to do a local open here to be able to access this body module everywhere. But this is going to complain to us in a second, right? Because we're trying to use this handle request method that is not really defined anywhere. So we should let handle request, and this will take the descriptor, the schema, and the context. And in here we can get some things from the Look, there's so much people here, I don't know what to do. I'm gonna panic. So right now we're just defining Marvel Cinematic Universe API. And the scope of what we're gonna be doing in this live stream is defined in the README. We're just gonna have a small, person type that will have some data for Tony Stark, Thor, and Gamora, and we'll be able to get things from it. You should be all right. Cool. All right, so now we need to handle this request, which means we need to use the request descriptor object to get information about the request, and we need to use the schema and the context to actually run some of the things. You may notice that this is the exact same schema that we passed in at the beginning, right? So here, what we can do is we can ignore the path, and we can always run something, but it will be interesting to essentially extract the target, which is the path that we're currently going to, and pattern match on it to be able to do some sort of routing so that you can point your client to a particular route within your server. So let's do that. The HTTP-AF module has a recti module that has has a way of building an actual request object out of a request descriptor. So if we do this, then this request object, it's essentially of type request-t, and if I just type that in there, you'll see that we get a method, a target, a version, and headers. Now the method is great for doing pattern matching as well. It's just polymorphic variants. The target is also great for matching on the path. And then the version and headers we can use for different things. This is a very low-level way of building the server, but it's the highest level this library HTTP-AF provides to us right now. And to be completely honest, it's the library I'm the most familiar with right now. I could barely do any core HTTP or core async stuff right now. It will take me another live stream to get familiar with it. All right. So now that we have the request object, we can just access it, and we can just say something like switch and request a target here. But we can also pattern match on, method. But we can also pattern match on the target, right? Now the target will be a string. The target will be a string, which means that we will have to pattern match on an exact string. And it's much nicer to pattern match on chunks of the string, so that we can pattern match on something like GraphQL, right? And then, you know what? We don't actually need this right here, right now. But if you were to use this to build your next HTTP server or REST server, you will likely do something like users, and this would be like an ID, because you capture this in a variable in a pattern matching statement expression. And then here you can do like a subsection or description. And then this will be able to, this will come from a URL that looks like users, 1, 2, 3, description. It's a nice way of doing a parsing of these things. But we don't actually need it right now, so we're going to use the call of the target, which begins with a slash. And we're going to say, if the method is get, right, and the, post, and the path of the target is GraphQL, then we'll do whatever we need to do for running this query on the service, because the body of this query, right, will be the thing that you're sending. For anything else, and we don't really care about any other thing right now. For anything else, we're just going to return a response saying that this method is not allowed. Cool. So let's do first the bad path. In fact, we can just remove this for a second, so we get this up and running, and we get all of the responses failing. And once all of the responses failing, then we know that we can get at least one response that's good, that would work. I mean, we can pattern match differently and pluck one of these requests from the rest and make it return something that's good. Now, if I remember correctly, HTTP-AF has a response module that actually represents responses. So we can create one by giving it a bunch of parameters, and I'm going to make, okay. I see the type here. It needs to take just a status. It doesn't need to take any headers or anything else. But of course, if you want the client to know that it has received the full response, you need to give it some header, at the very least content length, so that the client will make a request, and when it gets the data back, it knows, oh, there should be 0 bytes here. And so we can do this by saying headers, and then there is a module called, I'm going to do a local open here, headers. What? Headers that has a way of from list, and then we can give it a list, and this list is just pairs, where on the left hand side you have the key, and on the right hand side you have the name, the value, sorry. Okay, so here we have the headers, and then the status of the response is the next thing that we're missing. So if I say that for a second there, it did not reformat. There is something weird here. Line 3. Also do that, this is with this. Huh. It might be that the pattern matching needs an extra set of parentheses. Nope. What is it? Remove this thing for a second. Oh, yeah. There you go. Ah, sneaky semicolons. So now this is a function that will, if you give it a status, it will give you a response back. And if we give it something like what, it will complain and tell us that it doesn't know what that is. But I think we should be able to autocomplete this. Okay, if I start typing something like n, I'll get the rest of the values, and I guess that now that I'm autocompleting, I can just go all the way back to the tick. No, it didn't work with the tick. Okay. But there's something called OK, and now we want to use not allowed, not implemented. All right, not implemented. Cool. But the response, creating the response doesn't actually do anything. We need to actually take this object and send it. That is, we need to write this object in disk somewhere. And this is the part where I'll excuse myself because I don't actually remember how to do this. I have forgotten. So I'll take a look at the here. Okay, so Rick D had a response with string. Cool. So this will be a response, and then we just need to do request D BAF requesting. There's something wrong with my setup because I don't seem to be able to do a local open and then autocomplete by having that local open affect the scope. So here, in respond with string, we essentially want to give it a request descriptor, which is the thing we have above. We want to give it, if I look at the type response, we have above as well, res, and we need a string. And because the response will have nothing, we'll just return empty there. Cool. So this is the thing that actually does the response, and this is a side effectful computation, right? And how can you tell? Because it returns a unit. It takes too many parameters. It has too semantic a name to return a unit and do nothing. And then what we seem to be doing here is just return LWT unit, which I wonder why. So let's take a look at the signature of this. This should return a unit, but not an LWT unit. Okay. So if we do this thing here, right? We should probably pattern match on both. Cool. So line 13 now says this expression has type request, but T, right? My bad. We need a descriptor. Great. And now the server on line 23. Handle request should return a unit, and this is exactly where we wanted to do LWT async, and asynchronously we want to just run that thing on every request. Cool. Oh yeah, look at that. So many things. Let's make this a little bigger. This says on line 36 of the server module, right? Ooh. This pattern matches values of type blah 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 blah. which are all the standards. But apparently what's expected with matches values of type server connection error. Interesting. So this error type here is a server connection error. So I wonder if we can so this will be a server connection error. And does the server connection error have, I guess it would be inside of HTTPAF. Error, can we get the error as a string somewhere? So let's see the return types. I think we're expecting start response to do something other than this. And I'm gonna take a look. What is error here? No, you know what? There has to be something in server connection that we can use for dealing with this stuff. Okay, so if we there isn't. I don't see anything. I wonder if it's in another sub package. Like, yeah, definitely not here. Method, recti, response, status. Okay. I am not entirely sure why this is working fine. So if I do XBAF, that's server connection, and I do error, then it just tells me the type is server connection error. But of course I don't have access to that, but do I? Yes, okay. So this is what I was looking for. These are the 4 different errors that we can have at this point. It's either an exception that is trapped in there, or then it's bad gateway, bad request, or internal server error. So we can use some of this. So I'm going to copy them. And we're going to match on them. I'm going to say if it's bad gateway, bad request, or that one over there, right? And it's error. Then we're going to try to serialize this thing into a string. And I'm hoping that maybe status has something for us. What? No, status. Computers, am I right? Blind error, status, no. It's a string, takes a status. My bad. Can't use that there. Okay, that seemed to work. Now, I'm not entirely sure why the other ones didn't work. I also guess that we could do this. Bam. Nope. We're gonna explicitly list all of them. That should be okay. Worst things have happened. Okay, and we can just ignore the schema and the context right now here. Cool. So now we finished writing the server, or at least the first iteration of it. It's a little bit messy, but essentially we set up the HTTP server right here, and we're passing in the schema and the context here, and we can use it here, and then we keep running forever. Now the one problem we're having is that at the beginning of the program, we are expected to pass it also a port number. And I'm going to pass 2112 because I really like that album. But you can pass in whatever else you want. And we're getting some smaller errors, like the Dune file of the server is missing logs LWT. And then that runs. Okay, so now if we run this thing without any parameters, right, it should print out that we are running the server in localhost 2112, and it should hang. I mean, it should continue to run. It should just not finish. That's not good. It's not terrible because it's not finishing out and blowing up, but I would have expected something else to have happened. So we'll take a look at the small differences that we have. Oh, of course, we're never going to be logging anything. My bad. To be able to log things when we're using the logs library, we actually need to do a little setup beforehand to specify the level of logging that we're going to use and so on. And I'm going to just shove that into the main here, and I'm going to borrow it from another working file that I have. And we're going to be saying setup loggers. I'm going to take this little bit of code, and we just put it in there. Boom. Save. And of course, now we have to add some dependencies, but that's not the end of the world. We also will have logs, and logs.format, and format.tty. So if we do that, then we can run again, and there you go. We see that the server is running, and we don't expect to be able to query on anything. It should just do the curl there, right? Then it should just return immediately. We can make sure that we are actually running the server by logging every time that we get a response. So we can do the logs.debug. And actually, we will log every query. Let's say we'll do that, right? And let's say that we will do the method, and then we will do the path. That should be good, right? Requested math, and I hope there's something in HTTP that request. What the name? PP home. What the hell is PP home? No, maybe method. To string. Great. To string, and then we can do target, which already is a string. So if we say that and it builds again, then now we'll be able to show that every time that we're requesting things, they appear there. Cool. We've gone through this part. That's the least important part of it. We're going to go straight into the GraphQL side of things, and we still have around 40 minutes, and I'll of course stay as long as we need to make sure that we wrap everything up and it looks nice. Cool. So let's commit some of these things, just so that you can start looking at the code on your own if you want to. What did we change? We added some dependencies, so if you go to MCU, commit, add depth, and then we What do we add in README? I forget what the README looks like. Right. Add README, commit, scope out project or live stream. Damn it, live stream project. And now we can just say initial implementation. Whatever that means. You can tell that we're not actually writing that much code. We have 120 lines of reason, and that includes, all of the very spread out across multiple lines functions that we're using, which are not necessarily, they don't have to be written in that way, but the reformatter does that for us. It seems to optimize for code that spans the length of your screen rather than the width. All right, so let's go back to it. Now that we know that the server is working and that we can request things to it, we will try to read for when the method is post, right? And the target is GraphQL. We will try to do a few things here. The first one will be get the body of the request, right? And the second one will be execute the body, which will be actually parse the body into a GraphQL document. And then the third one will be execute the document with the context and the schema, right? And then we'll do serialize the response or the resulting value. And then we need to write this down into and then 5, respond with serialized resulting value. Cool. Does that make sense so far? We will get some query in the body, and then we'll have to parse the body into a GraphQL document, see if it's valid. If it's valid, then we continue. If it's not valid, then we need to return and say, hey, this is not a valid body. I think that right now we can just fail, similarly to how we're failing in the response error handler. And once we have the document, we just need to do the same call that we did before. So there will be a way of getting the body, right? And then we will essentially do doc, and this will be GraphQL parser, and then parse body, right? And then we will have the result, and that will be GraphQL schema, execute, and here we will pass in the doc and the schema context. And then to serialize this back, we can use JSON, so we can do a JSON string, and then we can do JSON.basic with the string, and this would be result there. And then we can return this thing by building a response. So we will do let response will be response.create, and then the headers will be of a list, right? And the list will have to have the content length, which will be the length of JSON string as a string. So if we do JSON string, this would be string.length, and then this would be string of int, because we have an integer, that's the length, but we need a string really. And then the second thing will be okay, if the response is okay. And then we'll be able to do HTTP AF, recd, respond with string, and then we pass in the descriptor. So where will we write this response? We pass the response, and then we pass the JSON string in there. And then we just, for the sake of the framework, we return a unit. So, I mean, one thing at a time. I'm gonna just put that for the formatting. But one thing at a time, we need to figure out how to parse this body, right? If we do that, the rest looks pretty much okay. It's something that we already did when we manually hard-coded a query in there. So we need to figure that bit out. And I'm going to look into request to see where the body could be. So in my head, the body is really something that we can access, we can read from the file descriptor, right? So we need to somehow get one of these body T if we want to have that. Right. But instead of looking around all of the modules everywhere, I'm just going to take a look at how they're doing here. And somewhere in here, when we try to execute a request, we do request body from regd, and that's how we get the request. Cool. Right, and then we're just going to be, all right, that makes sense. So if we read this bottom up, right, it begins by saying, I think I have a ping. Sorry, one sec, I have a ping on my phone, I need to address it. Can't believe I got rated. That's so cool though. I think if I get one more follow, I become a Twitch partner. I got an email for that. Which is cool. I have no idea what that does, but it's cool. Anyways, if we read the function bottom up, right, it says body schedule read. So schedule a read of this request body and use this function for reads and use this function for end of file. And then this is the function that we use for reading, which is recursive, and essentially reads, takes some request data and turns it into a string, right, by using this offset and this length, and just concatenates this thing into some variable, some body that we have somewhere. And woo, 50, nice. Thank you, mysterious follower. And then it essentially concatenates what we just read to the concatenated string somewhere. And once it's done doing that, it just schedules a new read. And it uses the same function so that it reads recursively through the request data until there's no more data. And when there's no more data, it calls end of file on EOF. And this function is the one that we see here. And this function doesn't actually get anything, right? It just gets a unit, and then you have to figure out what to do with anything else. And here is where a lot of, here is where the same thing is going on. They will essentially dereference the body string to get the whole string and then turn that into JSON by parsing it, and then essentially extract the query, right, as a complete string out of it. Ignore the variables. No, it's actually using the variables for something. Yeah, it's passing the variables in there. Okay. But at some point, it will just execute the query, and then you get a result back, and then on that result, you can check if it's a good response. Then if you get some data, then you just return the data by turning the data into a string with JSON, and then creating the response object, which is very similar to what we already have in place. The response is okay, and so on. Then you have to write this. So this is the little bit that I could not, for my life, remember. So we'll see if we can write this thing in a way that's more less jumpy around the code. I think we can do it. So that then the code looks more sequential, even though it might not actually be. So we can do read body, and then this thing will just get a request descriptor, and we will begin by saying next or promise and awake, and we'll just make a waiting promise, and then we'll just say next. So we'll return that, and then in a different thread, not really a thread, right, but asynchronous to this, we will do some work, and then this work will collect the string, right? And then once we're done, we're just gonna awake this promise so that when you read the body from here, like read body, and then you do like this. Then the next thing you can do is sequence, do monadic sequencing here, and then you get the body. And then you can just use the body in the rest of your function. Something like that. Which is still reads nicely, like top down, rather than, okay, beginning at the bottom, and then what do I do, and so on. But of course, that doesn't mean that this will look exactly as it is right now. We'll have to deal with some of this complexity as well. So right now, I think we could essentially look at how this is doing. We could essentially do the same thing, right? Inside here. I'm just going to copy the code, and then we can reorder it. But instead of running all of this stuff when the thing finishes, on end of file, we just want to awake the promise. If we save, and end of file. And then the file, we want to do LWT awake wake up, I think it's called. Yeah, wake up later, and then we'll use the awaker, and then we'll pass in the body string, the contents of the body string. And this should return a unit if I'm not mistaken. Yes, okay, that's good. So if we save, we should be able to do open HTTPF here. Request body. Alright, so now we need to essentially read the request body out of this thing, which means how do we do it here? Okay, that's just a function called request body that we can use. So body recb.request body. So if we call this with recb, then in here we can just use the body. Which I guess we can also do it here. Cool. So line 17 has a problem, and the problem with this thing is that we need to return something that is a promise. Right? So the type of this thing should be takes the type and returns the promise of the string. Yes. Cool. So this should be a string. Great. Now we can parse this, and this will be a result. Of course, we can parse this thing, and we can switch on it. Right. And if we get an OK, then we have a doc here that we can then use for all of these things. And if we get an error, then how can we bubble that error up nicely? Let's take a look at how they're bubbling errors. It'll be nice to. Okay, they have a module for HTTP utils. Okay, let's see what that does. So somewhere in here, right? There's another file that looks just like this. For responding with an error. Okay, so it's just using internal server error when it responds, and it's going to be building a string out of the error body. And the error body we saw is whatever the error was turned into a string. We can do that. For the purpose of clarity, we're just going to reuse the same code we have done here. Because the only difference is that we need to change the content length to be the same length of whatever JSON basic to string tells us this will be, right? So error string, and then string the length, and then string event. There you go. And then instead of not implemented, we can use internal server error, and that would be the error string. So that should cover our error case, which will return that. Now, whenever we execute this document, right, we will actually get something back, which you can also switch on. It's a result, but it's a slightly stranger one. And this result also has an error case, right? That we'll deal with it in a second. I need to tell it that it should return something so that the formatter doesn't blow up. Oh, my bad. I forgot to match on the good case. And when we match on the good case, we either have a response here, right, that has some data, or for the case of an OK that has a stream that we don't care about, we will just return unit as well. So this we will auto format now. 1, 2, 3. Boom. It wasn't too big, but it was a little. Okay, so line 40 now, it's complaining about something. Probably the order of the parameter is wrong. So the first thing is the schema. The second thing is the context. And the third thing is the document. That should be 1 or less. Yes, we are using our schema and context now, so we can uncomment them out. There we go. Great. We have a result thing somewhere that we're not using. Right, here. Data. That was it. And line 54, this should be uppercase K. And we have a typo in a function called respond with lowercase string, not uppercase string. Right. Cool. The type system is really just doing the work for me right now. I'm just, following what it says. Hey, go here, check this thing, change the other thing. So error is already a string, so we don't need to actually do anything with it there. Just get the length and then use it. And in here, the error actually is a JSON thingy. Okay, so now we can reuse this little bit of code. Right? I'm gonna just say let Respond with error, and then we'll have some error here, and then we'll do this thing, which means we also need to pass on the requestee, and yeah, that should be all. So this will take some object that we can turn into a JSON string, but I actually think that we can just use the error there. Cool. We'll need to do http://af.response create, and same for headers. There, str. Doing some renamings, but it's fine. Okay, so if we go back to the piece of code we have here, right? When we get an error, we want to turn first build an error string out of it, and then we can call respond with error, and we can give it the request descriptor and the error string. And for the case where the error string already is, the error is already a string, we don't need to convert it into anything, we just need to use it, so we can do error here. Cool. Wow, this built. I'm suspicious. Alright, but we've been coding for quite a while without even running this thing. So maybe it won't work. Maybe it will. Closing the server now, running it again. And what I would expect is that after adding this, right, into GraphQL, with the GraphQL at the end, we will get some weird error. Okay, this makes sense to me. And don't you hate it that GraphQL does this for you automatically? You. Okay. So we're using a post, so it should be okay. There's no schema available, and we're returning this thing. That's what we return. So if I query from curl, right, I get nothing. But if I do query, now this is going to be a get. Okay. Can I see the actual query that you do? Edit? No. I guess you're not going to show me, right? I wonder why. I wonder what is going on. We're clearly getting something, so we can actually log in here and say, oh, we got this body. So let's sequence this with the body, and then we'll be able to do logs, lwt.debug, and then query, and we can just put the query in there, body, right? And then we can just ignore the result and just put the body back in. This should build. There you go. Oops. No, this one. So now we should be able to debug every one of the queries. What I did there essentially is after you read the body, execute this thing, which means log this thing, and only after you finish logging, then return the actual body. If we didn't add this little bar, little bit again at the end, then this will log, and then the login returns units, and then body will be a unit, and then nothing will work. Okay, so we get something in there. That's good. I'm going to close this little one. And this looks like an introspection query. But we get a string back. So yeah, let's add some more login somewhere else. And in here we can do the synchronous thing. We can say logs, lwt, debug, and found document. Successfully parsed query, and then successfully execute a query. We run the server again after we build automatically, and if we run this again, boom, then we should see first the query, and then we should see the other two things. But we don't. And that means we're definitely not doing stuff here. Huh. One sec. I wonder if GraphQL parser is a predicate entry. Maybe not. Maybe it's the GraphQL schema. Okay. So we're definitely falling out into other branches. So I'm just gonna comment on this one. And here we'll do logs, error, failed. I'm just gonna put in the error here. So now we should also see the error on the terminal, if there is one. The error says string. What the hell? Okay, right. The problem is that this might not be obvious, but if you look at this thing, right, this begins as a JavaScript object, and I think we just forgot to extract the query. We only just need the string that's inside of the object. So it looks like we should do something other than what we did. In other words, once we have the body, right, we should extract parts of it. Basic, and then in here we can do, I think it's member. The member should be query, sorry, should be body, member, and then we should just say to string. I don't actually remember this part. As string. Just read, I don't know, it's a lot of things. What? I'll do the sensible thing. JSON to string. Okay. And now the body will actually be what's inside of that. This should be from string. This should be a member. Yeah, I could pass. So this will extract, take the whole of the body. It will turn it into a JSON object that we can manipulate. So we'll parse it. We'll extract the query, and it will take the query as a string. If we run this again, then we'll see here the exact same problem. Why? I wonder. If we invert these lines, right, then we'll see something different. Right, we just see the query there. We don't see wrapping query object around it, and that makes more sense. What else are we missing that this server here is actually doing well. Actually, we can do this in here. We don't need to do it in there. We can definitely do this in here as well. So the query will be that. We can just load the query and parse the query. Is that okay? Right. We had a single switch before, so it didn't need a brace, but now it does. I don't quite get though. This is a string, right? And it's a string that looks like what we want. Oh, but we're getting new lines everywhere. I wonder if that's messing up with parsing. But they didn't run into this. I wonder if they're sending me queries in the same way. Huh. Let's have a look at the docs for the library, and we'll find out whether it supports that thing or it doesn't. This is experiment. Nope. Where's the library here? So I don't know if the parser actually works with new lines or not. I would expect it to. But it's clearly failing somewhere. And I think that somewhere it would be here, essentially a parse line. Otherwise, we will be able to at least see successfully parse the query, which we clearly haven't. Why though? Why are we just writing string down? And could it be that GraphQL is doing something wrong? Anybody, any ideas? Yeah, could be a content type. However, I am not sure if we don't specify the formatting or the if we don't do something with the header for content type. I don't know if HTTPAF will do anything for us. Exactly, yeah. That's my intuition as well. It will do nothing for you. So whether graphical is setting up the content type correctly or not is irrelevant. So what I thought you were doing on Montero is that you took the query, right, and you parsed it into a string, and perhaps you did some formatting with it. For example, take all of the new lines and just replace over them. I'm not entirely sure how you. Yeah, precisely. We're not getting to the GraphQL part of the request, anyways. So I'm wondering if there's anything else that we can set around in the parser to make it parse this thing. Because right now it's just complaining at is it as read string util to string? Okay, gotcha. Yeah. So now we have a server there, and if we refresh this thing, da-da! Successfully parsed the query. Here's the query that we're using. Successfully executed the query. And look at that. We have a schema here on the left. I'm going to make this bigger so people can take a look more nicely. There you go. We have a query that has people that will return persons that are there. They have to be there. Yeah. And that makes sense. The parser should not need to understand JSON. He needs to understand GraphQL. Long day. And this is all the people in the Marvel Cinematic Universe. And if you go to people, it's a type person that has all of these fields. So my guess is that if we run this thing, and now we should have auto completion as well, yeah, we can get all of the data that we've defined so far. And we do. We get Mr. Stark, Mr. Odinson, and Gamora from unknown location. Wow, all right. This is a slice of the service. It's taking us a little bit longer because some of the tooling still is very low level, such as building the HTTP server. But we'll get there. We'll get to a point where you can use something like Connect or Express if you're into JavaScript, or Sinatra in Ruby land. That will let you essentially not have to deal with all of this. Oh, I need to parse the body in an asynchronous manner by requesting reads from some buffer, and rather just get the body if you need it, or get a stream of the body if you want to do that instead. But this is something to get us started. Okay, so we have the thing up and running, and we should be able to reuse this fairly easily as well. I'm surprised that we haven't put this particular GraphQL server in a more general library that you can just use. Maybe even part of GraphQL. I'm happy though that we can run it with HTTPAF. So let's go back into a README and say we want a person should have first, last name, and hometown. We want a query for the list of people. We should see these 3 people, and we see them, which is great. We've accomplished this. So I'm gonna do a small here, query for people, and say done. And I think we have time to do another one. I would like to do superheroes, so we can establish the the alter ego of each one of these people. So we can say that's a person, they have a connection to a superhero, and so on. So let's say query for a person's alter ego, which means a person should have an alter ego, which will be a superhero, right? When we query for the alter ego of all the people, we should see Tony Stark as Iron Man. We should see, yeah, that's the only one that has an alter ego. The other two actually have their own identities, are their regular egos, I guess. Woo, I'm so happy. Building GraphQL servers in Java is really, really not safe compared to this. Really unsafe compared to this. For alter ego of all the people, we should see Tony Stark as Iron Man. Cool. So now we can go back into a schema and continue doing some GraphQL things. And then we will need to add an alter ego field to the person, which will be a superhero. And we don't need to do the recursive relation right now. But a superhero essentially has a name, should be a string. We can start with that. But because the alter ego could not be there, we'll say that it's optional. So for example, for Tony Stark, the alter ego would be some alter ego with name Iron Man. And then for the rest, the alter ego will be none, because they don't really have one. Schema line 1, you know, type there. Cool. So now we need to add the alter ego field to the person, alter ego, and then their secret identity. Well, actually, it's not necessarily secret. Their alternative identity, yeah. And this one in particular can be null, so we should look for something that. All right, so we can just use a type here, a name, and we want to use something called alter ego that we have not defined yet. And when we get a person, we're just gonna extract the alter ego from it. Cool. So we just need to define now a new GraphQL schema object called alter ego. GraphQL schema dot new object, and this will be superhero. And then the documentation will be as superhero in the Marvel Cinematic Universe. And the fields are going to be just the name, really. So we can just take the name from here. And we always want to have a name. The name of the superhero. Cool. And that worked. That hooked automatically the alter ego type into the field for alter ego in the person type. So if we reload our service, which by the way starts really fast, we should be able to refresh this thing, and then when we go into the people, we should have an alter ego field that should have a name. So if we query for everything, then we should see, yeah, perfect. Okay, I'll make this bigger. We should see Tony Stark is the Iron Man, and the alter ego of Thor is just null. He's just Thor. He never hid his identity. Same happens for Gambar. At least not for the Thor that we have in the MCU, right? And we can continue adding more things. As you've seen, the hardest part of getting this set up and running has not been the GraphQL side of things. It has actually been the how do we serve this thing over HTTP. For further tutorials, for material, I think I'll keep an eye open in the difference between modeling the domain that we have, in this case the MCU, and how well it works with the language, which in this case it works great, because we can define a person that roughly matches whatever types we want internally. And the other part of working with GraphQL over HTTP, which is the HTTP part. And that's the part that's a little bit rough around here. But anyways, it's getting late. We've been over 3 hours working on this. I've learned a lot. I hope you've learned as well. I've learned not only things about GraphQL, but also about this particular implementation. And as always, I ended up, every time I touch LWT and HTTPF, I end up learning something new. For example, today I learned that when you are handling errors, right, the errors that you get back are not necessarily the same status code errors that you would expect. This is not an error handler for a response that went wrong. This is this is an error handler for a request that went wrong. So if the request is broken at some point, then you'll get this thing here. So if we throw at some point inside here, I expect that to just be some sort of catch-all. And I was happy to be able to encapsulate this little asynchronous pattern in a very, I would say sort of elegantish way, so that we don't actually have to read the function up and down all along, but we just say, all right, this thing will do some work, and then it will return the body at some point. And this is very linear, right? If we read through this, it's like request E, you read the body from it, and then you get a body, and that's it. So I think this was nice. Yeah. Thanks a lot for the suggestion of the MCU. It was a really good idea. I wouldn't have thought of that. Let's go into the say done. We can definitely scope more things to work with, but we don't necessarily want to do them right now. Thanks for everyone that's still listening and everyone that joined and left. The raid was insane. Thanks, Ninksayer88. I did not know you could raid people like this. I was so confused. And thank you for hosting me as well. This is another episode of Reasonable Coding. If you like this, and if you enjoyed my voice, my soothing voice, then you might as well go to events. Leave me a follow if you like that. But if you want to go to events, you'll see that we have a bunch of things that are going to be happening soon. I think some of this, especially the 28th and 29th, I'm going to have to shuffle around a little bit. I'm going to be helping my brother move. So and one of these two will have to be moved a little. But subscribe to them. There's some more coming on about a GraphQL testing server that essentially will be an in-memory server that we will define by passing in a schema like we have here, right? And when you run it, it will generate random data that matches your schema. So you can do fuzzy testing of your clients, for example, which is something that I've been meaning to do for some time at work. And now that I have a tool that has enough type information to do that, I figured I might as well give it a shot. That's going to be interesting to work with. It might take a long time though. It's the first stream of next year as well. And we're going to be dissecting some libraries, taking a look at some frameworks, and there's going to be some more things booked by the end of January after I come back from vacation. So thanks again, Ann Montero, Antonio. Thanks, Fernando, Xavier Villa. Thanks everyone else who joined. Have a beautiful holiday season. Yeah, holiday season. And stay reasonable. Yes. Oh, yes, I'm missing one more thing. This is the repo for all the code is here. You can have a look. Oops, did I not add it? One sec. Add everything. All the code is here. You can have a look at it. Refreshing, there you go. It explains the things that we were trying to do and whether we did it or not. And I will be amending, I will be working on this repo to add some more documentation. And I will 100% be taking a look at the recent GraphQL experiment that Monteiro set up as well, which you should have a look as well. I think it's look at that. It's a pretty, it's much more complete than what I was working with right now here. So yeah, that's about it. Oh, well, one last thing. There's a thread in Twitter that I'm going to be using to post whenever I'm going live soon, like right now or in some hours. If you want to keep an eye on that one and just like and retweet to help me reach more people that want to learn about Reason and are having trouble finding resources, then that will be very, very much appreciated. Okay, thank you so much for everything. Stay reasonable, and I'll see you next time.